Hi everyone, welcome to Lab 5. Today let's talk about related simple t-test and independent simple t-test. Before our lab, I want to tell you something important. Rita and I have uploaded the keys for homework and lab exercise. For example, if you want to find the homework 1 and lab 1 answers, you can open your Blackboard and choose course document, click lecture 1. So I uploaded the answers here. This is homework 1 answers and this is lab 1 answers. So now let's start lab 5. Firstly, let's look at related simple test questions. So let's look at the first question. In the statistics class, the professor wants to know if taking the statistics class will make any difference on the students' feelings about the statistic. First step, we need to state a hypothesis. Non-hypothesis is that there is no change in attitude, so the mu between two tests should be same. And our alternative hypothesis is that there is a change in attitude, so the mu is not 0. Step 2, we need to set our criterion, because the question didn't tell us which one is bigger than the other, so this is a two-tailed test, and df is 30 minus 1, because there is only one variable, so we need to use the total number 30 to minus 1, so our df is 29, and then we can use the t-table to find the critic t-value. The question told us the alpha level is 0.05, so we should use this line, 0.05, and the df is 29, so we need to find the 29 and then get the critic t-value, which is 2.45, and this is a two-tailed test. We got critic value is positive and negative 2.045. So we need to calculate standard deviation of the difference score. Like this, the result is 0.13. Finally, we should use this formula to compute observed t-score. So we need to use the mean of a difference score, which is 2 minus mu, which is 0, and then divide the standard deviation of the difference scores, which is 0.13. We got it from the step 3. The final result is 15.38. Then you can make a summary like this. Since the observed t-value is greater than critic t-value, so we can reject the non-hypothesis. Now let's look at question 2. Question 1 to test people's attitude about the company. So they want to know if there is a difference before and after reviewing the commercial. And this question we need to use R to conduct the related t-test. So here is the syntax for question 2. Firstly, we need to build two variables. One is before. You need to enter before data into the parentheses, like from 15 to 10, and then build the other variable after. Then you can enter the t-test code. Enter t.t-test parentheses before, after, and tell R the hypothesis is alternative equals two-sided, because this is a two-tailed test. The mu value is 0. Paired means these participants are the same and took 2 times test, so you should enter t means true, and then enter the confidence level. Because alpha is 0.05, confidence level should be 0.095, and then I can run it. In the console window, I can see the result. This is a paired t-test, and the t-value is negative 1.7724. Degree of freedom is 5. P-value is 0.1365, which is larger than 0.05, so the result is not significant. Then we can make a summary like this. You can see before reviewing score is not significantly lower than after reviewing score. The t-value is negative. Remember to tally the t and 5 represents the F value. The P value is larger than 0.05, so we can see there is no significant difference between before and after reviewing the commercial. The third question is very similar to question 2. You need to build 2 variables, first one for wife, the second one for husband. So I will skip question 3. So let's focus on independent simple t-test. Question 1, we need to conduct an independent t-test by hand, and then we can state hypothesis. The main difference between treatment 1 and treatment 2 is 0. So this is non-hypothesis. Alternative hypothesis is opposite. Then we need to decide the critical t-value. Critic t-value is positive and negative 2.306. Now we need to calculate mean and SE. The result is 3.768. Now we can get the observed t-value. So the final score is negative 0.531. So we can see we failed to reject the non-hypothesis. So you can draw a graph like this. This is 2 critical t-value, or critical t-value is in the white area. That's one, and we cannot reject the non-hypothesis. Now let's look at the second question of independent t-test. Now let's talk about the independent t-test. Firstly, there are 3 assumptions of the independent t-test. The sampling distribution is normally distributed, and then data are measured at least at the interval level, so we meet the second condition. Thirdly, we need to make sure variance in this population are roughly equal. Last one, scores are independent. From our question, we know we need to test the first assumption and the third assumption. So this is the syntax for question 2. We set 2 variables, A and B. Shapiro test tells us if A and B are normally distributed. If we run it, we can get a result. Here, we only need to pay attention to the p-value. It is larger than 0.05, so we can see variable A is normally distributed, and this value is also larger than 0.05, so variable B is also normally distributed. Then we need to test the homogeneity of variable A and B. So here we use the f-test. Choose the syntax and run it. So here is the result of f-test. We also only need to pay attention to the p-value. It is larger than 0.05, so we can see variable A and B has equal variance, and then we can run the t-test. So we use this syntax to run independent t-test. And we need to add this syntax. The variance is equal. Here is our final result. Like this, two-tailed independent t-test is used to test if the 2 brands are significantly different. The brand 1 is significantly higher than brand 2, mean standard deviation, and then the t-score is 2.98. Because p-value is less than 0.05, we can see there is significant difference between the 2 brands. However, if Shapiro t-test p-value is less than 0.05 or variance test p-value is less than 0.05, we cannot run 2 simple t-tests like this. In this situation, we need to delete the variance equal syntax, and then the R will run wedge test by default. Okay, that's all about our lab. Thanks for your listening.